Limit as x goes to 0 of sine squared of 2x divided by 8x squared. The first thing we're going to do is try plugging a 0 in for each of the x's. In the numerator, that'll give us sine of 2 times 0, and then sine squared means you take the sine first and then you square that result, divided by 8 times 0 squared. 2 times 0 is 0, so we have the sine of 0 squared, divided by 8 times 0 squared, which is a 0. Sine of 0 is a 0, so we have 0 squared over 8 times 0, which is 0. 0 squared is a 0 over 0. We have the 0 over 0 indeterminate form. Since this is resulting from trig functions together with power functions, we're going to make use of the identity limit as theta goes to 0 of the sine of theta over theta equals to 1. Now what we have in this problem is two sines, sine squared of 2x. We're going to isolate those. Now since they have matching phases, we can isolate them together in their own fraction by writing it as a quantity squared fraction. We always need to isolate the sine functions so that we can phase match them for the identity. Anything else remaining, which is the 8x squared, we can write into its own fraction. What we have here is a sine phase of 2x in the numerator. We need to phase match by putting a 2x in the other position, which is the denominator. Now to compensate for that, we will have a 2x in the numerator, but notice it's being squared in the sine fraction, and therefore we have to square it to compensate for it in the numerator of the other fraction. Alright, the next step is to simplify the other fraction by squaring the 2x that's in the numerator. We're actually going to leave this sine expression alone because this is the perfect identity. And we have this multiplied with 2x quantity squared, which is 4x squared, divided by 8x squared. The x squareds can cancel each other out, and the 4 and the 8 can cancel to a 1 and a 2. And we will rewrite this result. Limit as x goes to 0 of sine of 2x divided by 2x quantity squared times 1 over 2. We've perfectly phase matched sine of 2x over 2x, so that limit inside the square is a 1. And we no longer have 0 over 0 at this point, so we can plug x into any remaining x's, which there isn't any remaining x's, so we just have 1 squared times 1/2. 1 squared is 1 times 1/2, which gives us 1/2.